Pardon me. So we've got the webinars recorded, so that way you can watch them anytime you want. They're on the YouTube video. Just go under YouTube Young Engineers of Today, select Iowa. I also have a sign up list, so it'll notify you if you join, and it'll give you an email whenever a video gets posted. All right. Now, what we're going to do today is bridges, and probably Wednesday will be bridges too. We're going to be using some software to help you design bridges, but the focus to begin with is going to be understanding how bridges work, as you'll be going into your lab tomorrow to make some bridges out of connects. And then you're going to have a design competition. Okay? Any questions there? All right. Now, bridge fundamentals. Force associated with the bridge is compression. Think of a compression as a push. Standing on a chair is compression. All right? And in fact, let's go ahead and go right to, hopefully it'll pop right up for us. There we go. So, forces that are associated with the bridge, when you push, it's like stand up on a chair, that's called compression. If you pull it, it's considered tension. Think of holding a rope. If you want to use a rope to lift something, you have to pull the rope taut, don't you? You have to pull it. There's the old story used to be saying, this is getting them to do what I want is like trying to push a rope. Pushing or compression doesn't work well with a rope. Tension does. Shear is where top half is going in one direction, bottom half is going in a second direction. That can be one of the nastiest forces there. All right. Now, we're going to go to something right now. I'm going to post it for you. I want you to try this. Okay, copy link address. I'm going to put it here for everybody to see it. You're going to want to go in Chrome to this. I think it should send you this to it. It's Building Bridge. See right there, I just sent it to everybody. Go ahead. You can either click on that. It should take you to Building Big. It's a video by the folks at, here we go, Forces Lab. And it's a Nova on building bridges. What I want you to do is go ahead and practice on this a little bit. You grab this, you're undergoing compression. All right. Go ahead. It's 8:04 now. Let's give it a few minutes for everybody to try that. Okay. Raise your hand once you've done all the forces. Squeezing, stretching. With squeezing is compression. Squeezing, stretching is tension. You got bending, shearing, in other words, sliding, twisting. Go ahead and do each one. Let's play with those a little bit. Follow the link I've sent to you, Patel. Follow the link. I'll put it up there again for you. I'm going to put it up for everybody. If you click on that, you'll be able to get to it. It's real important. Everybody is here ready to go at 7 o'clock your time. All right, here we go. Got a couple people joining us now. All right. Raise your hand once you've gotten to play with each of the forces. I'll give you a couple minutes to do that. This is really good preparation for the lab you're doing tomorrow night. Got another question? All right. All right. Kishan, if you go down to chat, you can see the links are all right down there. Look at my screen. I don't know if you can see it. I'll pull it over here so you can see it a little bit, though I don't really like that because I don't want everybody's names being shown to the whole world. But it's right here. If you look on the right side of my screen, you can see if you go down to chat, look where your hand is, the little GoToWebinar software, and there should be a chat window, and this message being sent to everyone. I'm going to go ahead and send it again so everybody's getting this. And if worse comes to worse, go to Nova Building Big and select Bridges and look under Forces Lab. Did you find it yet? All right. I'm going to assume that we're good right now. And most everybody's gotten a chance to try this. I don't see that chat window. It's on the bottom right-hand screen of your GoToWebinar. Open up the arrows. You should see it up there. Folks, where are you seeing it on your screen? So somebody else that's seen the chat window, where does it appear? If you'll just write it in the chat, or you write me a question so I can show everybody and help him find this. Top right. Look at the top right. Thank you very much. Top right-hand corner is what everybody's saying. Mine starts at the top right corner and goes down. Did you find it? Yeah, go ahead. Okay, that shiny rectangle is what you're looking for. There's a small shiny rectangular box, and you have to push the arrow. There's a push arrow on this. It might be out behind your other screens. And I'll tell you what, it's under Nova Building Big Bridges. We're going to go ahead and move on. Go on to the next thing, Sean, and we'll have it on the YouTube. It's right there. You've got to. Do you know where to raise your hand? Can you raise your hand? All right. Well, somewhere by where you're raising your hand, there's a pull-down menu where there's a chat window, and then there's the blue link. Is it because I'm using it? I have no idea. I would think it should be there. I don't think Chromebook necessarily would have anything to do with it. Send me a screenshot later and I can point it out to you. For right now, if you go under Nova Building Big and select Bridges, you can get to the Forces Lab. So if you go to Building Big, so look, watch what I'm doing up here on my screen. If you go to Bridges and then Forces Lab, you'll get there. So again, Bridges, Forces Lab, you'll get there. Okay, partner? All right. Okay, we're going to come back to it in a minute. You can try it some more in a minute. The next thing we're going to all look at is the loads associated with bridges. You've got dead load. And that is the weight of the bridge itself. It's not the people standing on the bridge I'm showing you. It's the weight of the bridge itself. And oh, by the way, it's always an urban myth. You'll hear people say, they built this library and it's sinking every year because they didn't include the live weight, the weight of what the bridge is carrying. Honestly, that's a myth. We have no evidence. When you hear that story, there's really no reports of libraries that have built. And really, the architects would know what they're designing the building for, and the civil engineers. So live weight is what the bridge is carrying. Dead weight is the weight of the bridge itself. Static, the load is still. So it might be the people on the bridge, they're not moving, or they're moving, and that's dynamic. So Load is still, parked car on a bridge. Dynamic, load is moving, car motoring across the bridge. If any of you have parents that are engineers, ask them about it. Because they'll have taken a class on statics and dynamics. Those classes can be challenging. All right. Now going over here. You also have thermal loads. Loads created by the atmosphere warming or cooling the bridge. And that's a big issue. If you go out and look at your sidewalks, you'll see that the concrete that goes from piece of sidewalk to sidewalk, there's a little space. It looks like felt in between them. And that's because of this thermal uneven heating and cooling. Earthquake, you pretty much know what that is. Ground starts shaking. Might not be a big deal in Iowa or in Charlotte, North Carolina. It is a big deal in Alaska. It is a huge deal in California. Oregon, they're really worried about Oregon someday. Wind, now this is a force most people don't think about. It's significantly for tall bridges and buildings. The reason why, for example, many bridges don't have planks around them, that you can see the skeleton of the bridge, is they want the wind to pass through it. It is a very powerful force. If you're building any kind of skyscrapers in your town, you're going to consider wind. Now we're going to go back to this lab. We're going to go to the loads lab. Now let me go ahead and copy this link address. I'm going to put it right here for everybody. Yeah, someone wrote hello to me. Hello. All right, let me go to chat to all. I'm going to send this out to everyone. Whoops. Let me go down here, send to all. I just sent you all something. It's been good. Someone's asking me about my day. That's very nice of you to ask, but let me go over here and just get a little bit here. It's been a good day. Visited my son. The link isn't working. Who's saying this? John's saying the link here. Let me go here. I'll get another link if it doesn't work. All right, it's working here. So let me try copying it right here. I'll put it over here. I'm going to send you in the chat the link. I'm sending it to all. I'm sending you in a response to the question. It's been just put up there. I'm putting it over here as well. I'll put it up in the chat window. So I put it as a question. I just put it as a chat. All right. And so you get there. That's dead load. The weight of the structure, weight of the objects. Try it. All right. So go ahead and play with that a little bit. Put everybody's hands down. Once you've, raise your hand once you have it. Again, here's the link. I'm putting it in a couple different places so everybody can get their hands on it. Okay. Raise your hand once you've done. Weight of the object, soft soil, temperature, earthquakes, wind, vibrations. All right, raise your hands once you've got it, folks. Okay, let's try these 4 or 5 things, and then let's get rolling here, okay? Raise your hand once you have them. All right. I'm going to go ahead and go on now. Let me just ask this real quick. All right, let's go. Well, let me go ahead and go on to the next point here, and then we'll take it from here. All right. When we talk about building bridges, we use different materials. So right there is wood. And honestly, wood is what we made bridges for hundreds of years. It's cheap, if not thousands of years, excuse me. First bridge probably was a dead tree that our ancestors walked over. It's cheap, but it handles both tension and compression. Cons, it's maintenance costs. You got to paint it all the time. You got to take care of it, and it's fragile. All things being considered compared to, say, stone. Concrete. This is what concrete looks like, a little gravel and sand. The Romans were coming up with it. Theirs was actually better until very recently. Ours hadn't caught up to the Romans' concrete. It's cheap. You're making it basically like stone and sand. It handles compression really well. It's fireproof and, for all practical purposes, weatherproof. Doesn't handle tension well, and it's impacted by thermal load. It's impacted by the differences in temperature causes the contractor stretch. Remember, we talked about your sidewalks. Reinforced concrete helps with the tension. It's low cost because it's still primarily reinforced concrete is concrete with rebarb in it, some steel in it. And that's how most of our bridges are built today. It's low cost because you're mainly made out of crushed stone for the most part. It handles both compression and tension well. It's fireproof and it's weatherproof. Thermal loads still bother it a little bit. But if you look around, most bridges, most things are built this way with what's called reinforced concrete. Now, in the past, we have experimented, and there are times when you want to use reinforced concrete, it won't work. Cast iron is what we were originally using. You could form it any shape. You could make it at your factory, lay out all the pieces, and then assemble it like a Lego puzzle at the site. So you can make it at your factory, ship it out to the site, and they'd make it there. It handles compression real well, and it's fireproof. And honestly, this was built in Britain, in the 1700s. Beautiful bridge. The cons, it's expensive, does not handle tension well at all, and breaks without warning. So that breaks without warning thing and no tension, eliminated for most modern bridges. You might see a decorative bridge made where you know it's just a few people walking over it, but you just don't see it anymore. If we're going to make something we want that's beautiful, you do what they did with the Forth Bridge, this big thing. It looks kind of like a dinosaur. You would also use this with the folks that made the Golden Gate Bridge. They use a lot of steel in that. Forms in any shape. It can handle, steel handles compression and tension well. It's pretty fireproof. It's pretty weatherproof. You do have to paint it. It's expensive to build. we'd make all steel bridges all the time, but they're expensive to build and honestly expensive to maintain. The people that paint the Golden Gate Bridge start at one end, they paint all the way over the other end, and just start over again. They're continuously painting it. It'd be like a battleship. All right. On a big battleship, the painters literally paint always. They're always painting. They just go up and down. Okay. Let's look at a materials lab here again. I'll put it out for everybody to see it. Materials, it's going to show you the different kinds. You can play with it a little bit. You can scratch it. I kind of disagree with them on them saying that tension, wood is. They're just showing you it's not as strong as maybe some of the other things. See, that aluminum does it pretty good, but it doesn't handle compression well. So let me put this out so y'all get to play with it a little bit. Wood's just more fragile. It's not as strong as some of these other things are. But it does handle compression and tension. All right, so I just sent that link to everyone. And I also answered everybody in a question. Again, raise your hand once you've played with it a little bit so you get to experience these different things we use. But you look at the range, you can see it's pretty strong. Cast iron, you can squeeze it pretty strong. But it's very tight. It just wants to break when you stretch it. And then steel is pretty strong. Problem gets to be steel is the cost. So raise your hands once you played with them a little bit. Hey folks, do you have a Harbor Freight out where you all are? Do they have Harbor Freights in Iowa? Wondered if you were buying their gear and how well it was working. We're starting to use some of their stuff. It's very inexpensive, which makes you a bit nervous. The school, we tend to lose some of our tools faster than I would like. Yeah, favorite store. All right, who said that? Yeah, Caden. Man, you can go in there and it's just, they have really good sales on stuff, and then you went on and buy a bunch of other stuff you don't really need. But, I love going into those different stores, just looking around, figuring out what you can build and go home and build it. All right, we got Caden. Everybody, put your hands up if you've done it, so that way we know. Trey, if you're done. Keyshawn, have you ever figured out? Oh, good, you're getting it. Okay, excellent. Everybody, great. All right, let me just. Whoops, sorry about that. Drop over here. All right, so let's talk about bridge shapes now. Rectangles, which you see everywhere, like this bridge, classic covered bridge, it's rectangular shape. That's the least stable. Arch, was right here, and then you have these buttresses. And if you took your hands with somebody across from each other and you lean in on each other, and then someone holds their ankles, you'll see that you can really lean farther and farther out. Those abutments right here, or buttresses they're called. And sometimes we use the wall of the river, or if you're in a valley, you'll use the walls of the valley or gorge to be your buttress, and you'll build right in. This handles compression really well. There are Roman bridges that were built 2,000 years ago, we still use today, can handle compression. They would be very expensive to build today for lots of, for a pure stone with the stonework. That took a lot of slavery back then. The Roman Empire was built on slavery. All right, they had to win, constantly fight, get wars, get more slaves to do a lot of stuff they did. And so they had free labor, basically, because they would, in many cases, they would work the poor slaves to death. All right, then Army built a lot of their roads. Then you have triangle. Works well with both compression and tension, strongest at the points. So if you look, you see these triangles over here. There's a triangle shape. That works, and that's a truss bridge. So if you see a steel bridge or a combination bridge, you're going to always see these triangles. Another thing to go look at is the radio towers. Those are those big, long towers you'll see off to the right. You'll see little delicate triangles going all the way up because they handle both compression and tension very well. Most bridges today, oftentimes, are still built rectangular, even though they're unstable because they're using reinforced concrete. It's so strong, they're not worried about it. They give it a broad base, it'll work. And I brought in civil engineers, and they explained that to me. Where this is expensive materials, and you've got to maintain it so much more. But this is a perfect class where you want, the railroads put that in there. They didn't want to put reinforced concrete all the way into the river. It would block up the river there. Okay. If you ever, there's different gorges that'll use that. Okay, and again, not surprising, we have a shape slab. And let's go over here, shapes. And you can see which shapes work the best. We're going to go ahead and pull this over. We'll type it here. All right. Let me know once you've done it. You can use this to figure out which one adds weight as you go up and down it. All right. Now, let's talk a little bit about the history of bridges. In fact, let me do a real quick poll. I like to do polls to see how my pacing and everything's going. Okay. That's a funny poll. Did not come out the way I wanted it to. Raise your, how's my, do I need to go any slower? Raise your hand if you think I need to go slower. Okay, great. All right. Anybody thinks I need to go faster? Raise your hand if you think I need to go faster. All right. There's only about 10% saying go faster. So we'll keep this kind of pace right now. But I certainly won't slow it down. Rome was the first society to build great bridges. They're great bridge builders. You see these aqueducts. These bridges were holding the water up here that ran along the top. I've been to France, southern France, and you can still see the aqueducts. The The arch bridge is better than a post and bridge beam for river traffic. Why would that be? A post and beam bridge is just a bridge, like say, here you got post and beams going across, posts going in the ground. What's the nice thing about an arch bridge? What is it generally most arch bridges do? If you had just a regular concrete bridge sitting in the river, what's the problem with that? Somebody want to give me some ideas? Go ahead and answer me in a question or answer it in the chat. But what do you think? Or raise your hand and I'll call on you. Oh, so everybody's hands went down. Why do you think an arch bridge works better in a river setting than a classic post beam or truss bridge? It's stable, but a post beam bridge can be stable if you use a lot of trusses, triangles in it. What about the water? Does the arch allow a lot of the water to pass through it? Yes, someone's saying less stuff on the water, right. So it doesn't block river traffic. So that's why you tend to see arch bridges there. All right, then Britain, late 1700s, starts using cast iron. So now they can build these beautiful, intricate bridges. With doing stone like this, you had to build it right on site. You'd have to go get the stone, bring it there. Your masons would have to carve it out. With steel, you can make it in your factory, keep the quality control up, have one factory producing bridges for all over. You didn't have to move the people. And you build it on site. You put it together, assemble it like a puzzle. And, here's another beautiful bridge right there. Look at that bridge. Another British bridge. Gorgeous. This is not wire like we normally know for the bridge. This is actually just iron connected across from each other. This is not like it's different than a modern suspension bridge. A modern suspension bridge would have wire bundled in rows going all the way across. Okay. All right. And so here you go. It's coming across. Here's your basic suspension bridge. This part of the bridge is undergoing compression, the center part. And then these are all undergoing tension as they hang off the line. And probably the most famous one in the world is Golden Gate. Gorgeous. It is beautiful. Ever get a chance to go there, see it. It is an amazing bridge. I'm never tired of seeing it. It's very elegant. Look, they have these 2 points. They've got the cabling on the suspension, bringing your bridge, the rope over this way, and then it pulls down this way. So this part of the bridge is in compression. Much of the other parts of the bridge are in tension. Tacoma Narrows is a bridge. They get so elegant, and they kept making them thinner and thinner. That flexibility, by the way, that saves the Golden Gate in an earthquake. If you make it too thin, the wind will get disruptive. And you have what happened with the Tacoma Narrows. That's where the bridge is spinning back and forth and breaks. If you go, you can actually see the bridge begins to flex. There's a guy in a car, and he runs way out of the car, and then the bridge collapses. It was amazing. They had built, the bridge was very new, and the wind started spinning on the bridge, and it just tore it apart. Yeah, here we go. So you got this trade-off. You don't want the wind to mess up your suspension bridge. And if you ride on the San Francisco Bridge, if it's a real windy day, you can feel that bridge move up and down. I went on some bridges in New Zealand. They allow you to walk on the bridge. And when the traffic's on the bridge, it'll move 3 feet. It's amazing. It's a meter, they're using. But looking at it's about 3 feet, you can see the bridge go up and down as traffic's driving over top of it. But that flexibility, not so good in the wind, is great in an earthquake. All right, now, how many people have had a chance yet to download this software? Raise your hand. Why did they make the bridge thinner? Save money. And it was prettier. I mean, you look at, let me go on this. Good. Well, then I'll walk through everybody and then how to download the software. We'll do that today. So you're set to go. You start designing it. But let's look at some of these. Look at how pretty this bridge is. And to a certain extent, this bridge at Brooklyn, classic. But look at, and you've got these thinner, that again, elegant look. But you go to something like this. See that bridge? Looks to me like a dinosaur or something. Not particularly pretty. So they go to thinner, same materials, and there's an aesthetic look to it. And with bridges, they can be such an icon. Cities will say, we want you to make a beautiful bridge. We can do a cheaper bridge, but we want a bridge that shows us off. Here in North Carolina, South Carolina, you have the city of Charleston, and they just put in a beautiful cable stayed bridge. And now you go in their city, and they have pictures of this cable stayed bridge everywhere. So they will put. Now, so it sounds like we don't have a lot of people who've gone and installed this software. So that's what we're going to do now. Let me just tell you about it. We'll go through in a minute. We'll follow the same rules. We're going to have a competition. We're going to download the software. I'm going to give you 1 week. You're going to post your scores on Edmodo with a screenshot showing how you did it. So that way everybody knows you did. In the event of a tie, the first submission wins. And I'll give you a $20 gift certificate to Adafruit. So this, the whole Iowa, it's the 7th and 8th grade. But everybody in the class, you're competing against each other. High score. Adafruit is amazing. It's an electronics, build anything kind of store. So you might, let me show you. I'll pick it up here. And I also use SparkFun's another great place, but right there. So they show you where to make all kinds of different things. So we can start playing. So you can get LEDs, you can get materials, make your own little drums, all these different things. All right. And you're going to get Raspberry Pi, so it sits and does that. Okay. All right. So let's go about starting. Let's get rid of the Forces Lab. Okay. Now I'll get you the link. So we go up here. All right. I'm going to give you the link right now. Here, I'm going to send it. I'm putting it out here for everybody. This, the entire audience is getting this now. Folks, we're really going to have to wait till everybody's got this installed. So it's really important you're paying attention. Once you have it installed, we'll talk about that install. Make sure to tell your folks that what we're doing. Parents, if you're listening, totally safe site. They design. All right. So you go to this site right here. Click on, it says Bridge Design Software. The Bridge Design is now available here. Okay. I'm putting everybody's hands down. Then right here, we're going to click on that. Here it is. If you can't find that, if you don't see that, I'm going to go ahead and send it this way. All right, so you want to get to the site, and not surprisingly, all right, then we're going to go ahead and download. In my case, I have a Mac. Now, wait a minute. When you go to start downloading this thing, don't just click on everything. Just wait a second. Guys, it will download for you. Don't click on any of this junk here. Do not click on any of this junk. it will start downloading for you. Don't click on any of these other free versions, any of this garbage. Please don't. It will start downloading. And if you're really worried it's a Mac, I'll download it. We can share the file with you some other way, but do not junk dump on all the rest of this stuff. It should just start downloading, like mine's reporting. I didn't have to click on anything. Raise your hand if your program's beginning to download. We got a few. Okay, good. All right, and it says thank you for all this. So now you've got it. Mine's downloaded, so I can just get out of this now. So then I got a little more downloading going to happen here, I guess. I'm running the webinar, which is taking a little bit. It's eating up my bandwidth a little bit. Has everybody already started to download? It started downloading. You shouldn't have had to click on anything. It should just start on your system downloading. Mine's 71 megs. I'm 64 of the 71, so I'm almost done. All right, mine's almost done. Mine's done. Okay, all right, there's the image. I'm going to make a copy. I'm going to duplicate it, and then that way we have two. So for the Mac people, we're all set. All right. Now all you do is drag it right over here in your applications folder. All right, folks, raise your hand or tell me if you've gotten it down. It's been downloaded for you. Let me go ahead. I move it over a folder. If it didn't and you have a Mac, I can upload it to there, and I'll put it on the Windows. All right, it says, look, Windows requires XP or newer. It should run. Okay. And you may have to do it on a different computer. We'll get you on the Windows. Once you have it, like I drive mine in, so now I can go into applications. And I should have, let me see, let's go over here. Bridge Designer should be there. There's West Point. No, I'm not sure why it's not. There it is, Bridge Designer 215. It'll pop up, look like this. You know, and it'll say, are you sure I'll open it? You say yes. Yes, you can. This software is totally safe. Okay. And it gives you these tips. These tips are actually useful, so sometimes you want to follow them. And it's going to go through on, we're going to go through on how to do a bridge. If you've got, how many people have the software running right now? Raise your hand if your software is running. Okay. Here's what we're going to do. I had 2 of you. Okay. I will go ahead and put up, make a copy of the one file, the Mac file, and try to get the executable. And I'll see if I can put it on Edmodo for you guys, and you can download it if you got a Windows machine or a Mac machine. If you can't get it to install, see if your folks can help you out on the installation. You know, this is, I don't write the software, so I'm not sure I can fix how much, but I think you'll be okay if you can download it on there. All right. They really probably need to make as a Chrome version that, you know, it doesn't matter which computer you're using. I suspect that's what they'll move with. All right, now, so let's go back through here. All right, you know, this is a 213, but it really is the 215, same thing. You just download. And then once you have, hit create a new bridge design, and I'll show you this, folks, and I will slide the slides for you so you can go back and start to look at this. So I will upload these slides. I'm just going to show you so you can kind of get started tonight. It's only 8:48 now. I will try to put the program, both programs on Edmodo after I've uploaded the YouTube video. So by tomorrow morning, you should be able to get to the I will have both the Mac program up there and Windows program. All you have to do is download it. Create a new bridge. In the beginning, just go with the defaults. You're going to follow the rules. And this is like build a 2-lane highway across the river valley. You know, and then, are you participating in local bridge? Just say no, because we're not competing with that. We don't have to generate a 4-character code. And you can change your plans here with deck elevation and standard abutments. I would throw out to you. So like there's deck crossed, abutments, and all these things. First time through, I wouldn't do that. A lot of that. There's cable anchorages, points. Notice though, automatically there's shipping cost, site costs. So it considers everything. You're trying to make the cheapest bridge to hold the truck going across. A lot of time you'll see in different science competitions, build something to hold the greatest amount of weight, and it has to be the lightest possible. Well, you're measuring efficiency, but in the real world of engineering, they don't do that. What they do say is, hey, this needs to hold this much weight. We want a factor of safety of 1.5 or 2. So in other words, it's designed. We tell everybody the bridge can hold 10,000 pounds. Reality, it can hold 20,000 because it's got a factor of safety of 2. We make it twice as strong as we think we need it to be. And that's good because weather sometimes falls on the bridge. Sometimes people make mistakes. I'd be willing to bet, like in North Carolina, you have single-lane bridges that are limited to 13 tons. The reason they say that only 13 tons can go on the bridge is that's what a school bus is filled with kids. All right. So they build these small little bridges. They make sure a school bus can drive across it. So you can play with that a little bit. And as you keep doing this, you're going to see your total cost site keep changing. Then I would suggest that you start off, select the standard trust template, do a Howie trust, and I'll show you all in the actual software. And then do design by your name and hit finished. And then you're going to start all these different things you look at. Here's your tools, joints, and nodes. This connects things. There's your site cost. You need to fill in the areas in gray. The joints are all already in there for you, so you don't have to do anything for that to begin with. Down the road, as you use the software, you can start to do more custom. Then you click on this little bar here. That's why I'm using this highlighter. And you click from joint to joint. You have to connect this member bar to the joints. They can't go from, say, this to like this member here. It has to go from here to here is okay, from here to here is okay, from there to there is okay. Any questions? I just showed you a lot. All right then. By collecting that pointer tool, you'll be able to select on individual members here. That will then describe in this graphics bar on the right, which is kind of cool. So you can see exactly the stats on this one. Here it is. It's a bar, size of it, how much strong it is, that kind of thing. It's member number 36. All right. You click on the button up at the top to run the simulation. And again, you know, we're going, it's 8:52 and I'm running this all by you. Don't worry, I will have save these sheets for you so you can start playing with it. This is the red slashes, they fail due to compression. The blue slashes, detention. And if you click on any of these ones in red or blue that have failed, it'll bring up a chart on the right that you can look at and you can make changes to it. So you want to, you can do this with a couple members to change. Say you hit Control Shift if you want to select multiple members, and then you can change them to make them bigger, and that's this choice up here. I'll go through that in a minute. All right. Let me show you on the software itself if I was running it. Oh, shoot. Okay, I'm going to create a new bridge. I'm going to say, okay. If you have an old bridge, it's just going to save it for you and bring it up. So you bring this up. In the beginning, when the first time I do something, I tend to go slow. So are we in a competition with somebody else? No, so you don't need to worry about that code. Here is the deck elevation right up here. Standard abutments. I don't have arch abutments. I have no pier. If I put a pier, it starts showing up here. See, and you can put it in there. But notice what my site cost does with that. If I get rid of it, it's a question of almost $40,000 there. Then you got cable stayed anchorages. In the beginning, leave that all just this little same. Medium size concrete again, leave that be. And then do a Howie truss. Hit finish. And so what's going to happen is you have this. You don't have to worry about your joint tool. The joints there are already there. So down there, they're already set. So you can go across, you hit the joint tools. Notice there's no screen or anything coming up yet here. Look over here. You got your load test results. You're going to pop these. Don't even worry, they're already down there. Then you hit members like this, and you click from there. There you go. And you just paint them right down there. Notice this chart is showing up. I'll go to this pointer. See, and there's the load. There's the member details. You can click on each member. We can talk about strength versus light. So there's one there. There's one there. If I click here on this choice, it shows up right. Let's go. That's 3. That's 2. And that's 1. You can see them right there. So it'll show on each of those. Okay? And then you fill out the bridge, and then when you're ready to try the bridge, you hit the run. Guys, don't worry. Try them off. We'll have them for you. We're going to spend all day Wednesday working on this as well. Any questions? It's 8:56 now. Do you have any questions? I'm sure you do, but go ahead and try this bad boy out. All right, Patel, what's your question? Yes, Patel. Wait a minute, let me unmute you. Yes. What's your question, buddy?
What is the goal?
To build a bridge that will hold that truck going across the bridge. All right, for the least amount of money.
Okay.
Does that make sense? Right up there's a calculator. It's showing me how I'm spending my money right now. See that? And what you're going to do is you're going to figure out a way to get it so when the bridge, there's a truck. If the truck won't hold the truck falls in, the bridge falls apart. If it does work, then the truck travels across. So see if you can do it for the cheapest amount. Okay? Okay. Anybody else have a question? So over time, and we'll go through this more Wednesday, and I'm sure there's plenty of other resources on their website if you want to get a little bit of ahead of what you need to think about with each member. All right? Are there any questions for tonight, folks? Again, I will have the video up within 2 hours. I'll load up the PDF. I'm going to see if I can get that Microsoft Windows Pro version of this to download. If that's the case, I'll upload both the Windows version and the Mac version. You can install it on your computers. And I just wanted you to get a taste of what we're going to do. You'll get to spend time in class as we work through it. Well, if there's no questions, I'm going to go ahead and stop class now. All right, then. Good night, everybody. Go enjoy lab tomorrow. It should be a lot of fun.